Hello everybody. Hello everybody and welcome to Camp 2124, the laboratory portion to your lecture, to Organic Chemistry 1. My name is Hiver Fonseca. I will be your TA for the semester. And although it'll all be virtual, I hope you still get a positive experience, and I'll try to do my best to help you guys in this journey. Today we'll be talking about health, risks, safety, and organization. This includes many topics ranging from waste disposal to how to protect yourself, to what are the expectations in cleanliness and management of the lab that you would ideally be taking part in. So let's get started. So we'll talk about safety, how to protect yourself, and how to run the lab, at least the portion of your lab. And ideally, I would have walked you through all the features in the laboratory, but since we can do that, I guess I'll talk briefly about some of the instruments that you might find in a lab and also some of the equipment perhaps. So the number one priority in an organic chemistry laboratory, I guess in all laboratories, but especially in an organic chemistry laboratory, is to protect yourself. Chemicals are very dangerous, and you must have respect for the chemicals. They can be your friends, but they can also be your foes. And I guess the main goal after that is to learn. But I guess it goes hand in hand, because the more you learn about chemicals, the more you respect them, and therefore the better you protect yourself, right? So some of the things that I would be in charge of is to make you aware of possible accidents during each experiment. So there's many things that can go wrong in some demonstrations, in some experiments. But also another thing that can also be very important in protecting yourself is maintaining a clean environment. So there's, I guess, two things. You have to be knowledgeable of the materials that you're working with, the chemicals, and you also have to maintain an orderly bench and clean equipment. You don't want to have a lot of equipment on your bench, because then the chances of an accident they increase dramatically, right? So these images look like common accidents. Here there might have been an explosion because too much of a reagent might have been added, or maybe added too quickly, or maybe the incorrect reagents were added because the student did not take care in looking at which ones were being added. Maybe the temperature wasn't kept at the recommended limit, and here, well, maybe the container was merely dropped to the sink or to a floor. So it's all of our tasks to keep in check all these possible situations. Although there haven't been any tragedies at UTEP, as far as I know, there are always these tragedies in other universities. But luckily there haven't been any at UTEP. So moving on. Whenever something does happen, it is recommended to call campus police through extension 5611, because dialing 911, the police there usually are not aware of the campus, so then they will probably have to call campus police. When it comes to some other obligations that I will talk about, you wanna look at the extension for EH&S, the Environmental Health and Safety Department. They are in charge of, they're kind of the first responders for for minor related waste disposal, and also keeping everything in check when it comes to cleanliness, and that some of the safety features in the lab work correctly. So I'm pretty sure you've already had some kind of, well, maybe you have general chemistry experience in the laboratory, and we always talk about laboratory safety. And I guess it's obvious now that it's so important, and that's why we talk about it time and time again. And it becomes more important the more difficult or the higher level labs you're exposed to. Because now, for example, some of the solvents that we're going to be working with, they're even more dangerous, and they can cause cancer. They can cause reproductive effects just by being around them without protection. So we need also to remind you of the personal protective equipment that you have to wear every single session in the laboratory. That's why you need training every year, especially if you end up working at a research lab. You have to take the presentation every year to make sure that you're reminded of all the protocol and all the safety equipment that you have to be wearing, because we always seem to want to forget, but they're all necessary, of course. So next up we have the apparel, the protective equipment that you have to wear. So safety goggles have to be worn at all times, and these are goggles that protect all of your face. Those are the big ones that go like this, right? Of course, no food or drinks are allowed, and it's very important to note why. Especially with organic solvents, these might get dissolved, since a lot of them are very volatile. If you put your food in the bench, in the fume hood, some of the solvent might get dissolved in the food, and you might be eating benzene or something like that, which is really bad. Closed-toe shoes are very, very important. You might drop glass and get stabbed, or you might drop some acid on your flesh, and most of the substances are going to irritate skin very quickly. So just don't wear anything that might expose your skin. Work is permitted only during scheduled laboratory periods. So I guess what this means is that you can only be in the laboratory when I am in the laboratory, when Dr. Maiti is in the laboratory. You cannot be by yourself or in times other than the laboratory. You have to, of course, know the location of fire extinguishers, safety equipment, and exits. So I guess worst case scenario, if a reaction blows up in your face and you can't see because you have hurt your eyes, you must be aware of where the eye washing station is, especially if you're by yourself, which is another no-no in these laboratories of this level. But if in case you would have to be aware of where the eye washing station is, so you could help yourself. And hopefully in your laboratory always you get glass, like test tubes or LNMR flasks that are not cracked. So you should check always your glassware. It's definitely always better to not use glass that is broken. So in the old days, chemists would usually smell chemicals to perhaps identify what sort of functional group might be in a solution, or to identify a chemical. But since I've figured out that this is not the best idea, so never taste or smell chemicals. Don't try to eat them, and of course avoid contact of these chemicals with your skin. If you're working with an acid or a base and you have no gloves on, whenever you're pouring something into another base or vial or a container, some of it might run down its neck, especially if you're new at this, and it might get in contact with your skin. If it's an organic solvent, it might expose you to a higher chance of cancer or some nasty disease, right? So that's why you always have to wear gloves. And then we're going to talk about how to dispose of chemical waste. It's very important, and the Department of Health, Environmental Health and Safety really cracks down on this. So we have to make sure that everything is disposed of correctly. You must clean your work area. Whenever you use equipment like a heating plate, you have to make sure that you return it to its place where it belongs. And then you should have a compartment with your reflux kit, and that kit has to be complete all the time. So then you have to return those where they belong. Paper trash and broken glass each have their specific containers, and the paper trash, depending on if any solid waste, any solid chemical waste got in contact with it, then you might be split between two specific containers. The balance and prep rooms, they're always nasty by the end of a lab session, but ideally you would take care to always keep it clean. It takes real skill to do so, but I'm sure you guys can. So goggles are obligatory, gloves are necessary, lab coats are a must. They are essential. This is how eye wash stations look. Some of them are retractable and you can use them as a shower in case the shower is not present. The fire extinguishers at UTEP, they work to put out most of the fires that you might encounter in any lab situation. Not all fire extinguishers are made the same. You can use flip-flops, or anything that exposes your skin. If you were to look yourself at a mirror in the laboratory, your whole body should be covered in some way except parts of your face. And you can use shorts, of course. Not allowed. So again, safety is the most important objective of the semester. So you need to be knowledgeable of the chemicals that you will be working with. And for that, you can use SDS pages or your book to be informed of the dangers of these chemicals. And of course, you can ask me or your professor. So an example of a situation in the laboratory. Apparently, two students were in the lab unsupervised, so that was the TA's fault, and they had water bottles maybe opened and no eye protection. So without eye protection, anything that goes wrong in another fume hood or even in their own fume hood can potentially expose them and injure them. And water bottles, like I said, might catch anything that could be in the air and dissolve a solvent or any chemical that after drinking might cause you harm. And also, students usually wait after the TA has arrived to the lab. They usually wait outside the laboratory. Do not go inside the laboratory without your TA. It's not a good idea because then students start horsing around and joking around, and it just increases the chances of an accident. Do not enter the laboratories until the TA allows you. It is my responsibility to make sure that the students are following the safety rules. So I must always supervise you. You might find this annoying, perhaps, but it is necessary to ensure your safety. Again, safety is the primary objective of any semester of any laboratory. No drinks or food allowed. and you always have to be wearing your lab coats and your safety goggles. So this is an example of a sink with dried or drying glassware, and then racks, and you have a paper towel dispenser here. For perhaps you might manually dry all the glassware, or your hands, doesn't matter. And it also has its specific bin. This actually looks very messy in here. Please do not have that. Those towels belong in a specific location, the crumpled ones. This is another example of another sink. I guess it's called sink number 3. These are some of the cleaning tools that you can use to brush a lot of the glassware. Here's the eye washing station that you can actually get out from its station, so you can wash your eyes or potentially use as a shower. And the idea is to not leave any dangerous materials or broken glassware even around, or much less inside the sink. Sometimes the sinks clog and the water rises up in the sink, and if you stick your hand in the sink, there might be something broken, and you might get punctured. The glassware usually dries by itself for the next lab section, although it's always nicer to find it already dried completely, courtesy of the previous lab section. So the waiting stations. I have seen some horrifying scenes in the waiting stations. Do not allow this to happen. You should. I guess the main problem is that long lines form, and everyone's trying to rush in and try to get out as soon as possible, and so they start making these messes. Do not let this happen. This wastes chemical. This wastes money, especially if you're in a research laboratory. This will look really bad. So do not let the balance get dirty. Much less have this situation either. Always close the container and put it outside of the waiting station, and let the other student put it back in and use it the way you use it, and try to keep it cleaner, kind of like this. Of course, always use paper, waiting paper. Just put it on top. Do not pour the chemical directly into the waiting station. That's definitely not a good idea. Right, do not leave the chemicals near the balances. This, and I mean, think about why this might be the case. If this gets dropped by somebody who's not being cautious, then you'll waste chemical, because evidently it will already be contaminated and you can't pour it back in. Move all chemicals through the initial locations. These will usually be a jar or its storage room, right? And if you don't, then I'll be chasing you. I'll be making sure that you're being orderly and you're following these rules. I will make sure, especially towards the end of the day, that no chemicals remain in the waiting stations, and that they're outside in their specific lockers, drawers, or storage rooms. So about solvents. So there are usually three specific solvent types that you should know. Aqueous wastes, they're any container that has contained water as the main solvent. usually if it's another organic solvent that is kind of polar or mostly polar, like water, you would put that in non-halogenated waste. You only put it in aqueous waste if the main solvent is water. So like if there's ethanol in there, but you make sure that it's water, the main solvent that is there in aqueous waste. Halogenated waste is anything that has chlorine, bromine, fluorine, all those DCM you want to really put in halogenated waste. DCM is dichloromethane. It's a commonly used solvent in the laboratory, but you want to put that in the halogenated waste. Some examples of non-halogenated waste could include like acetone, which we use to clean and make sure that containers don't have any residual product of some reaction. Use acetone for that, acetonitrile, DMSO. There's so many non-halogenated waste. So usually anything that doesn't have chlorine, you probably would have to put in non-halogenated waste, except if it contains majority water, which then you put into aqueous waste. If you're not careful, an explosion might occur, especially if you put something like a base diluted in water that you are supposed to put in aqueous waste. If you put it in halogenated waste, for example, it might cause an exothermic reaction and potentially make something explode, which we don't want it to happen. Always label, I forgot to mention, always label your containers. Always label your flasks. Do not just leave these flasks like that in near or in the fume hood for waste. Finish the job, of course. If you're already there, please finish the task. The TAs do this, so you probably don't have to worry about that. But in case you become a TA, I guess you would have to fill some of these forms, which then are collected by Environmental Health and Services and Safety, the department. Use pipettes. Some laboratories use them. In organic laboratories, you should not use them again. Use pipettes have their specific container, so just leave it here. So used pipettes are considered broken in a way, and they're not used again. But the bulbs are recycled, especially if they're clean. When you use pipettes, do not use them horizontally. You have to use them downwards, because otherwise the liquid might get trapped in the bulb. And that in itself could be dangerous, because then, especially if you use the same pipette, you might use it for two chemicals that will react. So just be mindful of that. Sometimes empty chemical bottles will be or can be reused, but in this laboratory they should not be. So they shouldn't be left near the waste, especially if there's some residue here and there's a spill. There can always be an accident. Again, you always have to be thinking of all the possible ways that anything can go wrong. It's a little bit paranoid, but you have to do it because, again, safety should be your primary goal. Also here, for TAs, usually I will be the one writing what's here in here, but it's in good practice that you keep track of what your waste is. This is what a broken glass box looks like. They usually some of them are open like this, but they're long, so that there's a low chance of getting poked. So this looks like a very messy fume hood. It's a heating mantle, and this is the regulator for that heating mantle, for the heating mantles. Cables, especially keep track of cables you don't want to put containers near cables and then drag the cables or get them stuck somewhere, and then the container falls. And again, there's so many ways if anything can go wrong. I will be chasing you, making sure that your fume hood is orderly. Also, the equipment, if you can see these labels, they mean these labels mean that they belong to a specific fume hood. So usually you don't want to share what's on one. You don't want to pass it to another fume hood. So here, yes, this fume hood, as you can see here, it's 3B and 3A on the left. And so its equipment should contain that is labeled 3A and 3B. So yeah, 4A should be removed, since I guess this fume hood is labeled 3B and 3A, or something along those lines. Each student will have its own laboratory kit with glassware for a myriad of techniques. The biggest one that you'll be seeing is how to use a condenser for reflux chemistry. So everything that I've mentioned, your adherence to these rules will be graded, at least in the in-person version of the lab. And at the end of the semester, you'll usually have a jar with a lot of intermediates, or perhaps the products of some reactions, and we dispose of these in their specific containers. We do not keep them, as it would make so much more trash. Cabinets are emptied, and I'll work with you to make sure that you get rid of the containers in an orderly manner. So it's at this point, I would have been walking you through every station in the laboratory. In most organic labs, you will see perhaps a student IR, student NMR, which are machines for chemical identification. There will be a rotovap, which is a machine to get rid of a solvent and allow you to visualize the chemical that you just made. There are fume hoods, of course. There are jars. There's a bunch of jars. There's glassware everywhere, and sometimes it can look like a jungle, especially if it's your first time in a laboratory. But maintaining it clean and orderly will definitely be to your advantage. I will be showing you where the eye washing stations are, where everything for safety is, like a fire blanket or a fire extinguisher, where those might be, what to do in case of accidents. But since it's a virtual class, then I will not be doing that. So if you have any questions, feel free to email me. I'll probably email you back as soon as I can. So yeah, that's all. Remember these numbers. Thank you.